So now let's see how to make use of trigonometric ratio. We have derived them that are for trigonometric ratio. Hey, lower your voice. Trigonometric ratio. We have already derived all the value one after the other that we have. When we have sine 30, we say that one is nothing but 1/2. When we have cos 30, we say that one is root 3/2. When we have tan 30, that one is 1/3. Then at the same time, we derive for cos 60 as well. We say for 60, when we have sine 60, that one is nothing but root 3/2. When we have cos 60, is 1/2, and when we have tan 60 is root 3/1, which is just root 3. So at the same time, we derive for 45 as well. So when we have sine 45, that one is 1/2. And when we have cos 45, that one is also 1/2. And I told you, in some tests you can see they will write root 2/2, meaning they don't like this one. So either they use root 2/2 or they use 1/2. The two approaches still the same thing. So the last one we talk about tan 45, and we say that one is nothing but 1. So if you have to use trigonometric ratio, you don't need to use any calculator here. You'll be basing your argument on these special angles 30, 60, at the same time 45. Now let's see this example. They said find the value of sine 30, sine square 30, or let's say sine 30 plus cos 30 divided by tan 60, for example. Let's take a look at this. So let's say tan 30. I was asked to evaluate it without using calculator. So meaning without using calculator, meaning we are going to apply trigonometric ratio. So in the problem, what we have there is a sine 30 degree plus cos 30 degree divided by tan 30 degree. So I can just make use of the approach. So meaning here we have tan 30, from here, what we have for sine 30 is what? Sine 30 from here is 1/2. If I put that one there, that is 1/2. Cos 30 is root 3/2. Then divided by tan 30 is 1/3. Are you following? Now let's find the XM of this. The XM of 2 and 2, of course, we are going to have 2. So how many 2 can we get in 2? That one is going to be what? 1. 1 times 1, and we have 1. 2 in 2, and we have 1 as well. 1 times root 3, we are going to have root 3 divided by 1/3. So now, you can see, I've told you earlier, we can apply the law of reciprocal. When we have division between two fractions, division will change to multiplication. So the moment it's changed, it will affect this side. This will move up, this will move down. That means that we have 1 plus root 3/2 multiplied by root 3/1. So we are applying the law of reciprocal there. So by the time if I open the bracket of this, meaning these two terms, root 3 will affect them one after the other. So now the first one, that is let's put a bracket there to make it convenient. 1 multiplied by root 3, of course, we are going to have root 3. Root 3 multiplied by root 3, that's going to be 3. How? We have root 3 multiplied by root 3. That one is a square root of 9, right? And the square root of 9 is nothing but 3. Then all divided by 2 times 1, we are going to have 2. If I can even write this as 1/2 bracket of root 3 plus 3. So that means whatever we have to find the value of sine 30 plus cos 30 degree divided by tan 30, the value is 1/2 open bracket root 3 plus 3. So let's bring another problem using, let's see another problem. Let's look at this on the side. Evaluate sine 30 divided by cos 30 divided by tan 30 plus sine 60 divided by cos 60 divided by tan 60 degree minus sine 45 degree over cos 45 degree over tan 45 degree, all raised to power over tan square 45, for example. Tan square 45. Evaluate without using four-figure table. So meaning you are going to use the knowledge of a trigonometric ratio. So we have already have all the value one after the other. You can just make a simple substitution. For the first one, sin 30 is 1/2 divided by cos 30 as well is also √3/2 divided by tan 30 as well is also 1/√3. That's the first one, right? Good. So the second one we have here is sin 60. Sin 60 here is √3/2 divided by cos 60 is 1/2. Tan 60 as well is √3/1. You can see I'm just making a simple substitution since we have derived all the values of them one after the other. Minus sin 45 is 1/2 divided by cos 45. You can see cos 45. Cos 45 is nothing but what? 1/2 as well. Then tan 45 is 1. So now all raised to the power of tan square 45. Meaning, if you check your tan 45 here is 1. So meaning here what we are talking about is 1 square, right? Good. So now I told you if you have division between two fractions, if you change to multiplication, we apply the law of reciprocal. The moment it's changed to multiplication, this one will change. That is, numerator will go to denominator and denominator 2 will also go to numerator. So down here, I can have this to be 1/2 multiplying by, if it goes up, I will have 2/3 multiplied by this one 2, that's √3/1. That's the first one, right? Yeah, fine. So the second one we have here as well, the same method as √3/2. Now this is division now. So when division change, we are going to have times 2/1 times 1/√3, right? Then the last one as well, we have 1/2 multiplying by √2/1 multiplied by 1. So now, 1 square is 1. Now, so I can easily cancel all this. √3 can cancel √3 here, 2 can cancel 2 here. So what we have left is 1 plus this one 2 can cancel each other. This one 2 can cancel this. What I have here is also 1 minus, you can see this one 2, this cancel this. So we have left is also 1. So here, 1 plus 1, we have 2. Then 2 minus 1, we are going to have 1. So let's see another problem. Let's see please help me pass that my phone. Let's see some problems from the past questions. So how we are going to make use of the approach. Now let's look at this problem that we have from the past questions. Let me find the question from here. So this is the past questions. Let's check from here too as well if you can find like 2 or 3. Now in this problem, it said find the value of, the question says find the value, question 2, find the value of cot square 60 degree tan 30 degree plus sec square 45 degree. Square 45, right? So let's see how we're going to make use of that. Now, so let's see how we're going to solve this problem. They say we have find the value of cos square 60 degree tan 30 degree plus sec square 45 degree. Meaning, you can see here as go beyond sine, cos, and tan. But luckily for us, we have already discussed that one, how we can make use of sec, how we can change it to cotangent or cot. So the first thing I know, if I want to find cot, I know cot 60 is the same thing as 1 over tan 60. I've already given you the hints of how you are going to make use of that. So here I can have, so now tan 60 now. What do we have tan 60 from the table? What I have here is what? Is √3, yeah. Is √3. So meaning But in the problem, what we are looking for is that, okay, let's just firstly write down our out first. And I have tan 30 to be what? What do we have at tan 30? If you check it here, you can see our tan 30 is nothing but also 1 over root 3. Then sec. If you have sec, what is sec? You know, sec means the inverse of what? The inverse of cos. That is a 1 over cos 45. That's going to be 1 over. So cos 45 here is a 1 over root 2. You know, we have done that one earlier. If I reciprocate this, that means we are going to have root 2. So now I have all the values now. I can just substitute and find what I was asked to find. So what I was asked to find is a cos square 60 degree and 30 degree plus sec square 45 degrees. So let's substitute the values one after the other. Cos 60, what I have is 1 over root 3, so it's going to be all square because of the square that we have there. Tan 30, what do we have tan 30? Tan 30 is 1 over root 3 plus sec 45, we have it to be root 2. So it's also square, that's going to be root 2 all squared. We just make a simple substitution. So tan cos 60 is nothing but 1 over tan 60. And now from the table we have tan 60 to be root 3. That's why we have the other one to be 1 over root 3. Then tan 30 as well is opposite of our adjacent. When we get it using the trigonometric ratio, we have the value to be 1 over root 3. Then at the same time, sec 45 is nothing but 1 over cos 45. And I know that cos 45 is 1 over root 2 from here. So when we reciprocate this one, we have it to be root 2. So now I want to find the value of this one now. Now, you know, this one means I should square it 2 times. So if I square that one, here I will just have 1 times 1 is 1. So root 3 times root 3, of course, that's going to be 3. So we have 3 here, 1 over root 3. So if I square this one, you know, root 2 square means root 2 times root 2, and we are going to have 2. So 1 times 1 here, we have 1 over 3 root 3 plus 2, right? So now I can clear the fraction of this one. If I clear the fraction, what's going to be the XCM? No, XCM is just like, I want to combine the 2 together, right? If I combine them, I'll just have 3 root 3 here. So 3 root 3 in 3 root 3, we are going to have 1, right? So 1 times this, I can have 1 plus 1 in 3 root 3. That's going to be 3 root 3 times 2. I will just have 6 root 3. So if you want to go further, you can rationalize this one. You can still rationalize it if you like. And if you like, you can leave your result like this. Let's rationalize it. That means this one can be root 3. How do you normally rationalize? We use what we have as denominator to multiply numerator and denominator. So here now, that means that I can have 1 multiplied by 3 root 3. You can have the result to be 3 root 3. 6 root 3 times 3 root 3. Look at it, 6 root 3 multiplied by 3 root 3. The number we have outside, we multiply each other. At the same time, the one we have in the room, we also multiply each other. So 6 times 3, and we have 18. Root 3 times root 3, and we have 3. You can see the one we have outside, multiply each other. The number we have in the root also multiply each other. So if you look at this one, 18 times 3 now is 54. So here we are going to have 54 here. This is plus 54, all divided by, look at this one too, 3 root 3 times 3 root 3. So 3 times 3, and we have 9. Root 3 times root 3, of course, we are going to have 3. So here we are going to have 3 root 3 plus 54 divided by 9 times 3, and we have 27. So if you like again, you can still break this one down into 2, just like what I said earlier. Anyhow you leave it, it's still going to be what? It's still going to give you the accurate result. Even at the end of the day, you can have something similar like this. You understand? So anyhow you leave the values, so far you see the result. How do you the results determine how you are going to leave your final answer? So this is what we call trigonometric ratio. The only thing you need to do here, just master the value of them one after the other. When we have angle 30, when we have angle 60, or when we have angle 45. Each of them has their own standard value under the trigonometry ratio. So now let's talk about double angle now. Double angle. double angle. Double angle, it has a formula that we need to master. Double angle, where we are given two angles, double angles. So I will derive some and I will give you some to leave it as just to practice. Double angles. Let's take sine for example. If I have sine A plus B. Sine A plus B, look at the generation because it's two angles. Then if I have something like a sine 2x for example, you can see sine 2x is nothing but sine x plus x, double angle, right? So now, if I have sine A plus B is nothing but, look at the formula, sine A cos B plus cos A sine B. It's even easy to even master. That is, sine will come, cos will follow, and then cos will come, sine will also follow. So then, if I have sine A minus B as well, if I have minus now, you see the same approach, it's going to be sine A cos B minus cos A sine B. You see? So please, this is very important. You just have to master how to make use of them. If I have positive, it's going to be sine A cos B plus cos A sine B. The same thing applicable to when you have negative, it's still going to be sine A cos B minus cos A sine B. But in the situation, if I have cos, if I have for cos, you see the cos is different because the sign will follow. If it is positive, it's changed to negative. Like if I have cos A plus B, we are going to have cos A cos B minus sine A sine B. You can see it's different from the other one, right? Good. So if I have cos A minus B, for example, since I have minus there, that means I will use what? Yeah, good. That's going to be cos A cos B plus sine A sine B. So that means it depends. Even if they use the same alphabet, let's say I want to use like a sine x plus x, for example. This is nothing but what? That's going to be sine x cos x, cool? Then plus cos x sine x. So don't be confused about this one. It can be any alphabet of your choice. Maybe it depends on the problem that we are solving. If I have sine, or if I have cos, if I have cos, then we will be making use of that approach. So it might be double angles. If we are coming to triple angles, that if it is 3 or 4 or 5. Now, in some situations, let's say, how are we going to make use of this formula? And we also have for tan. I will derive that tan so that you can see how we are going to derive for tan. So tan A plus B, that one is nothing but tan A plus tan B all divided by 1 minus tan A tan B. And Simon 2, what is the problem? Be careful. So now, if I have tan A plus B, look at the formula. We said we are going to have tan A plus tan B divided by 1 minus tan A tan B. So if we can derive this one, I will show you the derivation of this one to serve as a bonus so that you will be able to know that in these are made easy academia, we are trying to give you the best. So if you see this one, you don't need to cram it because that one is somehow. So let's see the derivation of that. Let's say, okay. Let's say, for example, I want to derive the formula for tan. You know, recall, let's start from here. Recall that if I have tan x, remember, if I have tan x is nothing but sine x over cos x, right? So now, that means if I have tan A plus B, that one will also be the same thing as what? Yeah, good. It's going to be the same thing as a sine x, sine A plus B over cos A plus B. I hope you are following, right? Yeah, nice. So now we know, according to what we put now, we have a formula for sine A plus B as well. We also have a formula for cos A plus B. So you can substitute the two. That means this one can be, you know, for the sine, I told you, sine will come, cos will follow, cos will also come, sine will follow. But in case of the cos, it will follow each other. So here, and we have sine A cos B plus cos A sine B, then divided by, that's for the sine. Then for the cos, we have cos A cos B, and minus sine A sine B. So now, the next step now, you divide all through by cos A cos B. Divide all through, let me put it there, divide all through by this one, the one we have here, that is a cos A cos B. So meaning I will divide this value by this first one here, second one, third one, and the fourth one. So then here, we have this one to be sine A cos B over cos A cos B plus the second one to here, we have cos A sine B divided by cos A cos B. You can see what we are doing now is we are using this one to divide each of them one after the other, divided by this one too, and we have cos A cos B divided by cos A cos B minus the last one here as well, and we have sine A sine B over cos A then cos B. So now you can see cos can cancel cos here, right? If at the same time cos can also cancel cos here. So what do we have left here? All we have left now is sine A over cos A. And recall, if I have tan x over tan x is the same thing as sine x over cos A. So meaning if I have sine A over cos A now is nothing but what? But tan A, right? Yeah, good. So this one too. What are we going to have for the second one here? When I have sine over cos, what are we going to have? Very nice. Now we are going to have tan B all divided by. So you can see this one too. If cos cancel cos, cos also cancel cos here. What are we going to have left here is 1, right? I have 1 here minus. So sine A over cos A, that's going to be tan A, and sine B over cos B, that's going to be tan B. You can see we have proved that one. So whenever we have tan A plus B is nothing but tan A plus tan B divided by 1 minus tan A tan B. So how are we going to make use of this formula? Because they are very, very important. How are we going to make use of them? Let's list them somewhere so that you're using them one after the other. Let's see this one. Let me just put it here. If I have sine A plus B, we say that one is nothing but sine A cos B plus cos A sine B, right? So, and we said if it is negative, let's say we have sine A minus B, we say that one is nothing but sine A cos B minus cos A sine B. Then, in the case of cos, we say in the case of cos, the two angles follow each other. If I have like cos A plus B, for example, if I have a positive, it's change to negative, that one is going to be cos A cos B minus sine A sine B, right? Then for the case of cos A minus B, that means if it is in terms of negative, I can have it to be positive now. That's going to be cos A cos B plus sine A sine B. Now, and when we have tan, we derive that one for tan. If you have like a tan A plus B now, that one is nothing but tan A plus tan B all divided by 1 minus tan A tan B. So let's see how we are going to make approach of this formula in a problem. Let's say a question say like this. If let's draw the diagram. I have angle A here. I have angle B. So here I have 3 and 5. Here, let's say we have 6 and 10. And the question says find, must go 1, sine. Okay, let me make it more interesting. Let's say I was asked to find sine 2A, 2 sine A plus B, 3, let's say cos A plus B, or let's say cos A minus B. So let's see how we're going to make use of the approach of this one. I recall, I told you how to evaluate angles like 30, 60, 45. we have some problems that we can make use of that trigonometric ratio and evaluate them. I'm coming to that after this example. So let's say the third one, we have to find tan A plus B. So let's see how we're going to solve that problem. If you look at that one, I told you where the angle face is called the opposite. So this is going to be called the opposite here. This is hypotenuse. That means I'm looking for the adjacent here, right? So if you look at this one too, this is opposite. I have adjacent here, and here I'm looking for I have an hypotenuse. So that means here I'm looking for the opposite as well. So the first one, I can say this is x, and here I can say this is y. Let's first consider the first shape using Pythagoras what? And theorem. Good. If I apply Pythagoras theorem, what is the formula? The formula is hypotenuse squared is equal to opposite squared plus adjacent squared. I hope you are following, right? Yeah, nice. So what do we have for the hypotenuse from the first problem? What I have here is what? It's 5. Good. 5 squared is equal to, what do we have for opposite here? We have it to be what? 3. I have 3 squared. Everything that we have here is x. I have it as x squared. So 5 squared, it means 5 times 5. That's going to be 25. 3 squared means 3 times 3. That's going to be 9 plus x squared. So if I collect like terms, that means that we have 25 minus 9 equal to x squared. So here I can have x squared to be 25 minus 9. What are we going to have? Good. We are going to have 16. So if I square with the both sides, meaning x is equal to what? X is equal to 4. That's for the first shape. Now in the second shape, we can easily calculate the other side too as well, using the same formula, the same approach, as hypotenuse square is equal to opposite square plus adjacent square. So if you look at it, what do we have for the hypotenuse of this shape? All we have there is what? Yeah, nice. We have 10. That's going to be 10 squared. The opposite that we have is y. That's going to be y squared. Adjacent that we have is 6. That's going to be 6 squared. 10 squared means 10 times 10. Then we have 100 is equal to y squared. 6 squared, that is 6 times 6, of course, and we have 36. So if I correct like terms, that means that we have 100 minus 36 is equal to y squared, right? So 100 minus 36, and we have 64 equal to y squared. So if I cross multiply, if I square the both sides, here and we have y to be equal to 8. So that means in the first shape here, we have it to be 8, right? Now, we now have to find sine 2a. So we have to find, I just use this one to find all the three sides. We have to find sine 2a. Sine 2a. That means they didn't move outside from this a. If I have 2a, how can we break down the 2a? Yeah. It's the same thing as a sine. I want to break it down into 2 angles. So if I have 2a, I can see that one is the same thing as a plus a. If I said a plus a, what are we going to have? Very nice. We are going to have 2a. So now let's apply the formula. That's going to be sine a cos a plus cos a sine a. If you like, you can add this one together because they are the same. So if I have this one, I can have 2 sine a cos a. So now let's check what we have for the sine a. Sine a, so let's only find our sine first. Or before I can find sine here. What is the formula for sine? I know sine is opposite over hypotenuse. So from here, opposite is 3, and the hypotenuse is what? Is 5. Good. I can even check for cos as well. Cos is adjacent over hypotenuse. So from this shape, we have it to be 4, and hypotenuse we have it to be 5. You can see, before we substitute the values here, we want to make use of all the value we are going to get from A, at the same time the value we are going to get from B. So for tan A, the same approach, the same formula for tan that we have as opposite over adjacent. So from this shape, what we have for the opposite is what? Is 3. And we have the adjacent to be what? Yeah, to be 4. So now you can see, before I find the value of sine 2a, I've gotten sine A cos A at the same time tan A now. So I want to substitute the values now. So sine A is 3 over 5. Cos A2 is also 4 over 5. You can see it's very simple and straightforward. So 3 times 4, and we have 12. 12 times 2, I will have 24 over 25. Because if I multiply 2 by 3, I will have 6. 6 times 4, I will have 24. Then 5 times 5, I will have 25. So the second one, we have to find sine A plus B. That's when we need to apply this formula because the angles are not the same. Let's see how we're going to solve that. I can even quickly find my sine A is sine B here. You know, sine is opposite over adjacent. So the over hypotenuse rather. So what we have for the opposite here is 8. Can you see? That's going to be 8. Hypotenuse is 10. That's going to be 8 over 10, right? So for the cos as well, cos B, that is adjacent over hypotenuse. So we have 6 here over 10, right? So for tan as well, tan is nothing but opposite over adjacent, and that one is 8 over 6. So in the first one, I want to determine, the second one rather, the second problem, I was asked to find sine A plus B. So you can see in this problem, the angles are not the same. So since the angles are not the same, that means I have to use this formula. The same method, just like in the first one, they are A and A. That's why we have sine A cos A plus cos A sine A. So here too, since I have sine A plus B, that means I just have sine A cos B, then plus cos A sine B. So here we have sine A cos B plus cos A sine B. So now I can substitute the values of all the value I got one after the other. So the first one, sine A, what do we have for sine A here? Sine A that we have is sine A that we have is sine A we have is what? What do we have for sine A? Sine A that we have is 3 over 5. So now here I can have 3 over 5 multiplied by cos B. You can see this is cos B. Cos B that we have here is what? 6 over 10. Good. This is 6 over 10 plus cos A. Let's check for cos A. Our cos A is 4 over 5. That means I can have 4 over 5 multiplied by sine B. Sine B is 8 over 10. So that means here we have 8 over 10 here. So now I can just, if you like, to make it easier, so that you can quickly find the SCM, you can say this one is 50, 18, because 3 times 6 is 18, 5 times 10 is 50. The same thing applicable to this, 32 over 50. So now, the XM of 50 and 50, that means, of course, we are going to have 50 here. That's going to be 18 plus 32, right? So 18 plus 32, what are we going to have there? That's going to be 50 over 50, and luckily for us we have 1, right? Because if you had 18 plus 32, we are going to have 50. Then if you have 50 for that, 50 over 50, of course, we are going to have 1. Now let's check the next questions. They said to find cos A minus B. The same approach, cos A minus B. Since I have already known all the values of A's and all the values of B, so I want to find the third questions. I want to find cos A minus B. Recall, if you have a negative, that's why we are going to have positive, right? For under cos. Do you remember that? Yeah. So now the formula is cos A cos B. Since I have minus, it's plus sine A sine B. So let's substitute the values now. So what do we get for cos A? Our cos A is 4 over 5. That means that we have 4 over 5 multiplied by cos B. We have to be 6 over 10. That's 6 over 10 plus sine A. Sine A is 3 over 5. That's 3 over 5. Sine B. Sine B is, let's check for sine B. Sine B is 8 over 10 there. So we have 8 over 10. So to make it easier, you can just multiply this one together. 4 times 6, we have 24 over 50. This one too as well, we have 24 over 50. X of this one is going to be 50, right? So now 24 plus 24, of course, we are going to have 48. So let me do this one. 2 can go. 2 in 48, and we have 24. 2 in 50, of course, we are going to have 25. So now you can see the next one. Let me solve the next one. tan A plus B now. I want to find tan, we have derived the formula for that. That is going to be tan A plus tan B, all divided by 1 minus tan A tan B, tan A tan B. So let's just substitute the values. So for something about that, I can just quickly say tan A here is 3/4, the one I clean here. So let's substitute the values one after the other. So tan A is 3/4. Can you see? We have 3/4. Tan B is 8/6. We have 8/6. You can see the way we are putting that, divided by 1 minus tan A again, 3/4, tan B, 8/6. So now I can really do fraction of this one. If you like, that first one, I can see this is little bit as 3/4 plus, you can see I can divide this one. So 2 in 8, and we have 4. 2 in 6, and we have 3. All divided by 1 minus, even this one too, we can reduce it. 3 here 1, 3 here 2, right? 4 here 1, 4 here is 2, right? So now, let's see that approach. Let's see that one. So this is 1 minus tan A is 3/4 multiplied by tan B is 8/6. So I want to reduce the fraction of this one. I think these two, if I have 3/4 is nothing but 4/3, because you can go, then this go for this go for this. So I think this one can give us something like 1 minus 1, in which is going to give us, if you find the xm of this one, then over 0, you can see it's going to lead to something like infinity. So just take note of that one, how we are going to make use of this approach. Okay, let's just finish this one. I have 3/4 plus 4/3. This one is going to be 12, right? So 4 in 12, that's going to be 3. 3 times 3, we have 9. 3 in 12, we have 4. 4 times 4, that's going to be 16. That's 25/12, right? That's going to be 25/12. So now you can find this one and it to infinity or 0. So depending on the approach of the problem, just follow the same process and you get the same result. So even with this one, we have to use it to find either angle 60, either angle, the total angle we mentioned, we said we have 60, 30, 45. It's no problem. We have to find angle 120, beside 120, or so we are coming to that using the previous trigonometric ratio.